Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju P. In this video, we are going to discuss about one more important, that is the last topic according to your core syllabus of the statistical mechanics, that is the radiation law, that is black body radiation and Planck's distribution law. In the 19th hundred, Max Planck derived a concept. That concept is the photon concept. Based on this photon concept, he derived one distribution law, black body radiation distribution law. So among the distribution law, he kept some hypothesis. Based on hypothesis, this question is came. Right now you have to see, for a black body radiation in a cavity, photons are created and annihilated freely as a result of emission and absorption by the walls of cavity. So you know that so the photons means you have to take it as a photons. Photons means these are the boson particles. You know that if it is boson particle, the chemical potential is equal to 0. The chemical potential is equal to 0 means it is freely rotating from one side to another side. So there is a created and annihilated the emission and absorption by the walls of cavity. This is because what? This is because of the chemical potential of the photon gas is equal to 0. Option A is correct. Now option B, C. So photons obeys the Bose-Einstein statistics. Photons obeys the Bose-Einstein statistics. So that's why these particles we call it as a boson. It cannot obey the Pauli's exclusive principle. Photons are integral spin particles, but so here, so the photons are, we are not considering the spin. The entropy of the photon is very large, so it is a very small. The entropy of the photon is very small because the chemical potential is 0, is freely so rotating, created and annihilated. There is no disordered state is there. So that's why the entropy of the photon is very large, is not correct. Which one is correct? For a black body radiation in a cavity, photons are created and annihilated freely as a result of emission and absorption by the walls of cavity. This is because of the chemical potential of the photon is 0. So like this you have to remember. Otherwise you able to take it as a, suppose you have to take the photon gas, you able to take so this photon gas is freely rotating, created and annihilated, emission and absorption is takes place. So therefore that number of photons gas is equal to constant. So the number of photons gas is equal to constant means so the dn is equal to 0. So dn is equal to 0 means what we have to write it is so dn is equal to, which one we able to write it is summation of I dni is equal to 0. Summation of I dni is equal to 0. But we know that alpha into summation of I dni is equal to 0. Here so this dn is not equal to 0. You have to take here. So dn is not equal to 0. You able to take so the n is a constant. You have to get it as a dn is equal to 0. You are going to write it is, so you able to take summation of dn is equal to not equal to 0. You are going to get n is the constant value. So that's why you have to write it as a summation of dn is not equal to 0. You are going to write it is not equal to 0. So therefore you able to take alpha is equal to 0. If alpha is equal to 0 means alpha is equal to minus mu beta. If alpha is equal to 0, you are going to take it as a mu is equal to 0. So that is the chemical potential is equal to 0. For what? Chemical potential is 0 for a black body radiation. This is the assumption of the Planck. This is very important. Already I am informing you CSIR and GATE physics. So we have one institute, that is the Quantum Online Academy. We have app. So through app you able to take all this theory, DL and physics and JL physics also you have to take. So our courses will display like this: CSIR and GATE physics, JL physics and DL physics. So the individual papers also available. till now these 4 papers are finished. So this 5th paper also almost finished. One advanced syllabus is there, that one also within a couple of days I need to finish it. Clear? So please share and subscribe and like and touch our bell button. Thank you so much. We will meet you tomorrow with another video. Thank you.